Alright, so if you've ever played Legos, you know that you can get a basic set. They come in these buckets and they have all the different size of bricks. You got 2x2, 4x4, 2x4, and from that you can do quite a bit. But in order to make an AT-AT walker from Star Wars, you know that you're going to need specialized pieces. The cones and the little transparent little blocks and stuff to make it look like an AT-AT. In organic chemistry, the basic pieces, like those bricks, are alkanes, alkenes, alkynes. But there are many, many different specialized pieces that you can add in order to create even more types of organic molecules. Derivatives of hydrocarbons are different molecules that can be built on the hydrocarbons. Some examples: alcohols, drinking alcohol, it's a hydrocarbon plus OH. Carboxylic acids are very important to us during Easter time because we need vinegar in order to make Easter eggs, color Easter eggs. But if you're down south in Florida, you may encounter fire ants. They will give you a carboxylic acid that'll make you remember never to step on a fire ant hill. Also, if you're not water, you're probably made up of carboxylic acids. Proteins are carboxylic acids. They're called amino acids. Esters, fruity smells, perfumes. If you ever walked up to somebody and you go, oh, ugh, they need to take a shower, that's an ester. If you can smell it, it's probably an ester. Our noses are attuned to smelling esters. And that's the C double bonded to an O bonded to an O. So this is going to be C bonded to an OH. This is C double bonded to an O, single bonded to an OH. And then this is C double bonded to an O, single bonded to an O, and then that O will have another C attached to it. Esters. Esters. There's ethers, ketones. There's more stuff than that, but I'm not going to teach you that stuff. That's for college.
The smell of cinnamon and rotting cadavers, compounds that can remove nail polish, power a car, knock you unconscious, or make your headache go away. All of these things can be accomplished by simple organic compounds with different functional groups sticking off of them. Yes, I said functional groups. We will be talking about them a lot today. Now, when chemists started studying this stuff, they didn't always know what really made one chemical different from another. Only that certain compounds, though different, often behaved similarly. Some smelled like fish, some had relatively high boiling points, some reacted in similar ways with the same compounds. Now, however, we know better. We know what they are, where they come from, and why they act the way they do. We are deep in the knowledge of organic chemistry's most powerful tools. It feels good in here, so dive in, join me in this solution of ethers and esters and aldehydes and amines and alcohols, but like not literally, because that would be super gross and you would probably die. Thus far, we have only discussed organic compounds involving carbon and hydrogen and nothing else. And yes, carbon and hydrogen are the backbone of organic chemistry. In fact, 1, 2, and 3-dimensional combinations of carbon atoms are the backbone of most organic compounds. But today we're going to throw a couple newcomers into the mix, 2 of my very favorites: oxygen and nitrogen. Using these 2 extra elements, we're going to talk about 7 exciting and different functional groups. But first, what is a functional group? It sounds super boring. Well, organic chemistry is the architecture of chemistry. With it, we don't just study chemicals, we build them. And we know that certain groups of bonded atoms function in very specific ways. Since we know how these functional groups function, we, and by we, I mean the human race, can add to or modify or remove or join them together in predictable ways. And thus we can build the compounds we need, whether simple stuff like acetylsalicylic acid, aspirin, or something more complicated like alpha-5,6-dimethylbenzimidazoleal cobamide cyanide. better known as vitamin B12. Neat, right? When we talk about functional groups, we get so focused on those small areas of the molecule that the rest of the molecule doesn't actually matter that much. So we use R to represent the rest. R just represents any fragment of organic molecule that we're not super concerned with at the moment. We also sometimes call the area of unconcern the R group, as opposed to the functional group where the business is getting done. So now that I've been talking at you for like 3 minutes, let's actually look at what kind of trouble nitrogen and oxygen can get up to in an organic compound. The first and most familiar oxygen-based functional group is the alcohol, a terminal OH. Not terminal in that it will kill you, though ethanol can kill you, and other alcohols like methanol absolutely will kill you, but terminal in that it ends a carbon chain. Now, impending confusion alert! There can be functional groups inside of functional groups. We've already seen 2 of them. If an OH is part of a larger functional group, we refer to it as a hydroxyl, and if a carbon double bonded to an oxygen is part of a larger group, we call that a carbonyl. For example, if we have a carbonyl bonded to a hydroxyl, that, my friends, is a carboxylic acid. Hopefully you're getting the hang of the lingo. Just looking at this carboxylic acid thing, if you think about the electronegativity of those 2 oxygens, you can imagine that that hydrogen there is going to be pretty weakly held. And so it can dissociate in solution, making it an acid. Carboxylic acids are the acid part of amino acids, which make up proteins, which make up you, so they're pretty important. The simplest carboxylic acid, commonly known as formic acid, is what makes fire ant bites burn, and just 1 more carbon and you get acetic acid, or vinegar, which even in the diluted solution you have in your cupboard is not something you want to get in your eyes.
Alright, so what are the rules for naming alcohols? Very similar to all the others. Count the number of carbons in the longest continuous chain. Number the carbons in such a way that the OH is on the smallest carbon number possible. Write the number of carbon previous to the OH, and then replace "-ane" with "-ol". Replace "-ane" with "-ol". What? Just write it. Oh, it's on the next page as number 1. Name the following alcohols. Randy. 1, 2, 3, 4 with an OH.
I don't get this.
What is the prefix for 4 carbons? Yes. We're going to just add the AN in order for it to make it sound better. And then, because an OH, what do we add to the end? Look on your rule. Ol. And where is the ol located, Randy? One, 2, 3, 4, or 1, 2, 3, 4. 1 butanol. Not O, it's old.
Yeah, I know. That's what I said old. I said old the first time.
Kelsey, son of Pater. Not good enough, because there's several versions of this. 3-hexanol. Can you imagine all the isomers that could be? Let's go back to this one. 3-hexanol.
Where's the hexanol or hexanol?
Hexanol. Let's go back to this one a second. I forgot to show you something. Emmy, give me a isomer of this. What? Very good. 2-butanol would move the carbon over to the second. All right. Somebody give me another isomer of this.
3.
Why would 3? What if we move this over here? Because it'd still be 2. You just number it from the other direction. Give me another one. No, there's definitely one more.
4 butane.
No, because that would be the same as 1.
Oh, yeah.
Okay, let me give you a clue. We've exhausted what we can do with the OH.
Oh.
You could move it like
What if we were to cut that?
2 propanol.
What would that be called? All we did was cut this off and put it in the middle. 2-methyl 2-propanol. You know what that's called? There's another name for that. Isopropyl alcohol. Isopropanol. That's rubbing alcohol.
Oh,
That's rubbing alcohol. If you just have the CH3 there and the OH out the end, that is called N-propanol, or I'm sorry, 2-methyl 1-propanol is usually just called N-propanol, normal propanol. All right, how about this one? Isaac. One heptanol. Describe it for me, Emily.
Oh, snap. Okay. So it'll be 7 carbons. And the OH is going to be above the first one. Or next. Okay. Does it matter if you put it
Nope.
above or next to?
Nope.
Okay.
How many more H's?
I'll go 2.
8.
2. 2. 2. 2.
Ethanol. Serenity. Ethanol. It's ol, so what does that mean? Everyone needs to be on the spot at all times. Because I don't take volunteers, I volunteer you. Ol means there's an OH. So where will the OH go? Okay. Why did I not put a number in front of the ethanol? What will it matter? It's either 1 ethanol or it's 1 ethanol. There's only one possible ethanol here, and that's 1.
Why did you put HO?
Because the C is always bonded to the O. It's not bonded to the H.
You wrote it backwards.
But what if you put
Well, I
it
wrote it
above?
backwards. What? So this would be OH, 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 OH.
What if you did it the other way around? It's still
It would be wrong. Because hydrogen, if you did it like this,
No,
it would...
I mean like on the other side, like OH.
Oh, yeah, that's fine. But if you did it like that, why is that wrong?
Because hydrogen can only bond one.
Hydrogen can only bond once, and there you have it bonded twice. 3-octanol. Jeffrey.
8 carbons. With an OH bonded to the third carbon. 5.
So how many H's?
And then 3 on the other side. 2, 1, 2, 2, 2. last one because I think I got
Yes, Randy, go.
the 5C. And then OH on the second one. It doesn't matter either side, right?
Nope. How many H's?
3, 1, 2, 2, 2, 2. Last one is for now.
Good job, Randy.
Now, there isn't, 31 is different on your notes, but this is correct. This should be 31. Name and draw 2 carboxylic acids. Let me give you the 2 simplest carboxylic acids. A C double bonded to an OH, single bonded to an OH, double bonded to an O with an H. It's 1 carbon, so we use meth. We add AN in order to make it sound better, and then because it is a carboxylic acid, we end it in oic. Oic. Oic acid. That is methanoic acid.
What is that in?
Well, I've already told you this, but the common name is formic acid. Some people are extremely allergic to formic acid. So much so that you have to carry with you, whenever you go out to nature, you have to carry with you an EpiPen, an epinephrine pen. Bee stings, fire ant sting.
What does that do?
It'll make your heart start working again.
You inject it into yourself and it releases this chemical and it'll help you it's an antihistamine. Anytime I take a strong
It'll shut down. Formic acid, if you're allergic to it, will shut down your whole system. It'll constrict your arteries and veins.
What causes people to get like erections or face?
It generates
Is that
what? It generates so much histamine.
Histamines causes you to swell up. And a histamine is a reaction to a foreign body, to something that's toxic to you. Who's ever gotten formic acid inside of them?
Oh, God.
Yeah, a lot.
what is formic acid?
It's bee sting, fire ants.
Oh,
Randy, have you ever been to South Florida?
Yeah.
I mean, when we would go play football in the field, in the park, we would bring fluorescent orange spray paint, because the first thing we would do when we cordon off our field is we would find where the fire ants. We wouldn't find whether there is fire ants hills or not. We would just find where the fire. If you're in South Florida, there's a fire ant hill within a few meters of you. Okay, so what we would do is we would just basically spray paint big orange circle around the fire ant, because kiddos, if you fall on it, they're on you in less than a second.
Me and my brother poked it with sticks, and
They'll climb up the stick fast.
The stick, it just filled up with them, and
Yes.
we didn't have time to react.
Oh yeah.
Yes, it is. And they will, once they get on you, they'll start biting and they'll continue biting. And they inject formic acid into you.
And it was weird because they were on my hand, and then I had bites on my leg, because they're everywhere.
And they're just super fast.
It sucks.
How about this one?
You can't drown them either. Yeah.
No, they'll actually float on the water and they'll land somewhere and keep going. All right. How about this one? If this is methanoic, what would this be? Ethanoic acid. Ethanoic acid. Okay, and what is this found in? Well, it's vinegar. So it's in your foods. It's what you're going to need in order to color your Easter eggs.
Wait, so how come it doesn't harm us?
What?
Like, are you talking about food coloring eggs or the plastic?
Look, why would you use vinegar in the plastic one?
Yeah, so why doesn't it harm? Okay,
Die,
so
plastic
that was my
bag.
question. That's my question. Why doesn't it harm you when you eat it?
What?
Like, why don't you feel anything?
Okay. Vinegar. Okay, that's a.
You eat the dried eggs.
First of all, vinegar. We're going to find out that there's a difference between strong acids and weak acids. All of these are weak acids. Okay, and vinegar is diluted even more. Vinegar is about 2 to 4% vinegar and 96 to 98% water. So it's really watered down. What the fire ants give you is super concentrated. Okay, and just adding one more carbon, and now you no longer have a toxin. Now you have a food. Vinegar. I mean, we Hispanics, our salads are oil and vinegar. Okay, we use vinegar to actually open up the pores in a chicken egg and allow the dye to work its way in. And then when we put it in water, the pores come back together. If you just leave it there, eventually the shell will completely dissolve in vinegar.
Oh yeah,
Okay.
it's like bouncy.
Yeah. So, next carbon would be, what would we call this? Propanoic acid. Propanoic acid. All right? The carboxylic, why is it important to us? Because we're made of amino acids. Guess what? Those are acids. Those are carboxylic acids. All our amino acids that our proteins are made up of end in this kind of configuration.